How are you, everybody who is watching this video? I would like to take this opportunity to welcome you into our interesting program of learning the beauty of fundamental practical electronics engineering. My name is Olenjolai, and I thank God by His own grace. I'm an electronics and telecommunication engineer by profession, but also I thank God by His own grace, I'm teaching students from the beginner level, intermediate, and even to advanced level about electronics and the telecommunication engineering. I would like also to welcome, firstly, all the physical students who have been a part of this class. And these are the students who are doing ordinary diploma in electronics and telecommunication engineering at the Dar es Salaam Ministry of Technology. And also we have some students who are doing bachelor in electronics and telecommunication engineering at the Dar es Salaam Ministry of Technology. And let me just greet them and appreciate their presence. How are you, class? How are you, my student? Okay, so you hear that they are fine. I would like to take this opportunity to welcome all the online students to join us into our fantastic moment of learning and grasping different concepts of electronics engineering. But before we go into our today's contents, let me answer one of your questions. Maybe this is your first time to meet with our contents, and then you are asking yourself the question that these contents have been prepared for who? That's a good question. The answer of that question is, these are the contents that will teach you about fundamental practical electronics engineering from the beginner level, intermediate level, and even to advanced level. So if you're a student who is doing ordinary diploma or bachelor degree in electronics engineering, these contents for any students that are doing ordinary diploma or bachelor in telecommunication engineering, those students who are doing mechatronics, students who are doing mechatronics engineering, students who are doing computer engineering, electrical engineering, all the electrical field related fields, these contents are very important for them. So if you're a beginner, this is the nice place. And I want to tell you that this is chapter 4. We have covered chapter 1, chapter 2, chapter 3. So make sure that you join or you visit our channel that actually you can access the previous contents and even the future contents. The last thing that I would like to ask you, before you subscribe, before you make a decision that to make this platform to be actually a permanent learning resource for you, I think that it's better if you go through these contents or this workshop that I'm going to teach you, and then at the end you may decide that to be a part of it or actually that to leave it and forget about it. So today we are going to learn about resistor, and as just you have written that this is workshop 4.4, we are done. We have learned 4.1, 4.2, 4.3. And then, if that's the case, I think that you are ready, you are technical personnel, you love electronics, let us go into our today's workshop. So, let us do the quick review of previous, workshop 4.3. So, this quick review actually links or join workshop 4.3 and workshop 4.4. So students, what did we learn? Firstly, in workshop 4.3, we learned the concept that we call it measurements parameters. Measurement parameters of fixed resistor. So in electronics and electrical engineering field, we have to know about the measurement parameters. So when you say the measurement parameters, it means we measure resistor of resistance of a resistor by using the following measurement parameters. And then they say that basically we can have different parameters such as temperature. We can have a parameter such as temperature coefficient or coefficient. For example, resistor has coefficient. You can measure resistor by using its resistance, power rating. Can measure also, the another measurement parameter of resistor is temperature, because a resistor can be affected by temperature. So we have a number of measurement parameters, but in this fundamental program, we are going to focus only 2, right? The first one, which I have mentioned, the first measurement parameters that we are going to learn is the parameter that we call it, student, resistance. Say resistance. Say resistance. So resistance, we say it is a property of a resistor or a property of any substance. Are we together? And then the second parameter, which I have mentioned, is called what? Power what? Power rating. Say power rating. So this might be a new terminology for most students because we don't teach the concepts of power rating in O level, in secondary school, and even just in advanced, we don't teach the concepts of power. We just teach the concepts of 40, resistance, and how we can join them in parallel or series or in complex network where we have to use what? Kirchhoff laws. Do you remember them? Do you remember them? So this is the new concept that we are teaching students, especially who are beginning the journey of learning the beauty of electronics engineering. So we say the power rating. So and then we discuss in detail about what? Resistance as the parameter. Okay? So with this parameter of resistance, I taught you one principle that you have to know. And the principle is this one. We say that resistance of the resistor might be small value or might be large value. Okay? So we have high resistance resistors and low resistance resistors. Are we together? Are we together? Are we together? And then we say that the relationship between resistance and current, we say that the relationship is inversely proportional. Why it's inversely proportional? We say that if a resistor has high resistance, then it's going to conduct low. So if a resistor has high resistance, it's going to conduct low amount of current. Are we together? And then we said, I taught you also in that workshop, if a resistor has low resistance, that's what I'm writing less than, then this one is going to conduct a large amount of current. Are we together? So for that case, it means that even you refer Ohm's law. Ohm's law states that voltage is equal to current times resistance. And then we say that divide by current, divide by current. So resistance is equal to voltage over current. So the relationship between resistance as measurement parameter of resistor is inversely proportional to current electricity. Are we together? So if you wanted to allow a large amount of current to pass through a resistor, you have to make sure that you choose a resistor that have low resistance. Are we together? If in your system that you want a resistor that will allow a large amount of current to flow into another part or another network, then you have to choose what? You have to choose for high current to flow. It means you have to choose a low resistance resistor. Are we together? Are we together? Do you remember that? And then we enjoyed, I told you that resistors are not made in any value of resistance. Right? So resistors are always made in terms that we call them, we have something we call it standard resistor. Standard resistors. Say standard resistors. Say standard resistors. So then, in case that we wanted to use a resistor for a resistance, which is not within the standard resistor, we have to use the technique of joining resistors either in series or parallel. Are we together? Are we together? So with this concept of standard resistors, then I taught you one principle. For instance, a standard resistor, one of the standard resistors is 1 ohm. Right? The second one, the next resistor is 10 ohm. So you add a single zero. Then the other one is 100 ohm. You add another zero. Then another standard resistor is actually 1000 ohm, which is 1 kilo ohm. Then another standard resistor is 10,000 ohm, which is 10 kilo ohm. Another one is what? 100 ohm, which is 100 kilo ohm. So this is the way that you can memorize different standard resistors. We have so many standard resistors, but you as the technician or engineer, you can memorize them by using this principle that I taught you. And I gave you a table. Are we together? Then I ended this workshop 4.3 by teaching you the concept that how can we get some other values of resistance of resistors which are not standard. Right? Then I told you that the concept, the technique, you have to join resistors in either in series or in parallel. With the concept that when you join two resistors in series, you are increasing resistance. You are reducing current. If you join a resistance in parallel, you are reducing resistance. You are increasing current. Are we together? Are we together? Just to remind you for the matter. We say, for instance, in your design, you have found that the resistance that you want, you want a resistor that its resistance is 122 ohm, for instance, for example. So, in the list of standard resistor, we don't have any resistor which has resistance of 122 ohm. Are we together? But that's what I have or I need in order to meet the requirements of my design or my implementation, right? So this one, how can you get 122 ohm? Simple. The good thing is this one. There's no need for you to estimate. We have a standard resistor, R1, which is 100 ohm. Are we together? Are we together? Yaki. Then we have another one, which you can call R2, which is 22. These are the standard resistors, right? So to get a total resistance of 100 and 122 ohm, that is simple. How? It means that I will take these two resistors and join them in what? In series. So I will take these two standard resistors. This is 100 ohm. This is R. And then here we have voting. So this is R2. It is 22 ohm. So this is R1. So it means for this case, equivalent resistance is equal to R1 plus R2. Right? So from there, you can get R total, which is what? 100 ohm plus 22 ohm. So for that case, we have what? 122 ohm. So it's not an excuse to say that, the voltage which is being calculated is not within, is not the standard resistor. Are we together? You have to think how to take 2 or 3 or 4 resistors, connect them in series or in parallel, or both series and what? And parallel. And that should be good, because from there you'll use your mathematics of thinking and calculating. Are we together? For instance, if you don't know, you need a total, what I taught you, 122 ohm. You don't know, maybe 22 ohm is there. Simple. What you have to do, so you just need 122 ohm, and then R1, you say, let me choose one standard resistor, which is 100. Right? And as I told you that, call this one unknown resistance R. Okay? So this is simple now. We have 122 is equal to 100 plus R. Make R the subject. So 122 minus 100, you get 22 ohm. You go to the list and then you find 22 ohms is there. So you have 2 resistors, but they just performing one function. Class, are we together? That's what we have learned last time, and I have done actually even a long review. But it's actually advantageous to link, because these concepts of resistance and power rating are very important. Are you ready for today's workshop? Okay, so today, let us discuss about the power rating. Class A, power rating. Again, say power rating. Remember that there is the power of pronouncing terminologies in electronics. If you pronounce terminologies in electronics, and that's the trick that I'm using, you'll never forget them. Power rating of fixed resistor. Say power rating, power rating, power rating. Say again. So this is the new terminology. The fundamental question, question number 1, what is power rating? What is power rating? What is power rating? What is power rating? So he said that what is power rating of a resistor? What is power rating of what? Of a resistor. Okay, so I found 2 definitions, different ways that you can define this terminology, but I found just 2 definitions which are very powerful. So the first definition is the power rating. The power rating of the resistor. The power rating of the resistor is the maximum, class A maximum, both online and offline student, both group of students, online and offline students, say maximum. Do you remember about maximum power theorem? Do you remember about maximum pointing and minimum pointing differentiation and point of inflection? Okay, maximum amount of power. So it's a maximum amount of power that a resistor can dissipate without damage. Can dissipate without damage. That's the means of power rating. If you are a friend or you are safe, be asking yourself, what the means of power rating? Power rating of a resistor, because we have power ratings of different electrical appliances. So the meaning of the power rating of resistor is the maximum amount of power. Say maximum amount of power that a resistor can dissipate without damage. So if it exceeds that maximum amount of power, the resistor is going to be damaged, or it's going to blown out, or it's going to be actually that defective. Are we together? Or in other words, the resistor power rating, or the power rating of a resistor is defined as the amount of heat that a resistive element can dissipate for an indefinite or indefinity of time. Without degrading its performance. Degrading its performance. So these are the two definitions of power operating. All online, all students operating, online and offline operating. Listen. The first definition, the keywords, we say that this is the maximum amount of power. So whenever you hear power rating of a resistor, that's the maximum amount of power. What should come in your mind, right? And then we say that it's the maximum amount of power that a resistor can dissipate without damage. So when you say that it is passion, it means this is the transfer of energy, right? Transfer of what? Energy. And this transfer of energy, whenever you see the word dissipate, it means that there's another form of energy which has been transformed into heat. Are we together? Remember, dispersion is one of the functions of the resistor. To dissipate what? And a special power resistor. We wrote that power resistor, the power resistors are used to dissipate some amount of heat in electronic circuit. Are we together? So it means that when the current flowing through this, for any resistor, there's a dispersion of power. Some dispersion of power, it means that because actually in the resistor we allow current to flow, we allow electric current to flow. So there's a transfer of energy from what? Electrical into what? Heat. Right? So there's some amount of dispersion which causes damage, and some amounts of dispersion which does not cause damage. Class, are we together? The second definition is the power rating of resistor is defined as the amount of heat. So you see now another form of energy, right? The amount of heat that a resistive element, say resistive element, that resistive element can dissipate an indefinite time at a particular time without degrading its performance, without degrading its actual, reducing its shorty, or without affecting its performance. Are we together? Are we together? Are we together? In other words, we can say that power rating, say power rating. Power rating is the maximum amount of power that a resistor can withstand without damage. This is very important terminology I want to tell you, my student. So you say that, in other words, the power rating of a resistor is the maximum amount of power that a resistor can, or a resistive element, let's say a resistor, can withstand without damage. Remember that the resistor does not have power. Resistor does not have what? Either fixed or variable resistor. Either linear or non-linear resistor does not have power. If it is not connected in source of power, a resistor does not have what? So when you say power rating, it's the maximum amount of power that a resistor is the maximum amount of power that a resistor can withstand without what? Can withstand when current flow without what? Damage. Are we together? Yeah. So I think that, have you understood the meanings of power rating? So I think that you've written in your mind. Okay, so let me give you introduction about this terminology. We say that the resistor power rating, this terminology also in some of the books or articles or journals is sometimes called what? The resistive. So let me write in capital letter. So when you be reading some books, whenever you find this term, the resistors wattage rating. The resistor wattage rating. So in some of the electronics books or electrical books, whenever you find that they are talking about resistive wattage rating or wattage rating, say wattage rating. Say wattage rating. So whenever you hear that there's a discussion or teaching about wattage rating, actually we talk about power rating of a resistor. Okay? So this should not be a vocabulary for you from today onwards. Are we together? Okay, fine. That is good. Then resistors. So you say, resistors, I'm trying to give you build a foundation. The resistors can also classified based on how how much current it can allow, how much current it can allow to pass through them. And these current that can be allowed to pass through them, this is called the power. This is called the power or wattage rating. Wattage rating. So in simple language, this sentence, listen, separating this sentence, we say that resistors can also classify based on how much current it can allow to pass through them. And this property we call it power or wattage rating. It means that we can use the measurement parameter of power rating to classify resistors. Are we together? Are we together? You can use the measurement parameter of resistance to classify resistors. And how you can classify? We have low resistance resistors and high resistance resistors. Are we together? So based on power rating, I think that you have copied it or you have finished to copy. In case that you're still lagging behind, you can stop the video and copy. So based on power rating of resistors, we can have two classes of resistors. Classes of resistors. Classes of resistors based on classes of resistors based on their power rating. So you say that in electrical and the electronics engineering, we have two classes of resistor based on their power rating. Based on their power rating. So you have two classes of resistors. How many classes of resistors we have, student? Two. The first one, we call it low power resistor. Low power what? Low power resistance. Say low power resistance. And the second category, we have high power resistance. High power resistance. Based on what power? Rating. So let us just discuss this first class, low power resistance. Low power resistance. So you say that these are the resistors, which have low power rating. So these are the resistors which have low power rating. Means they can withstand small amount of current to pass through them. Examples we can have. So stop writing. See these examples. We have 1/10 eighth, or simply call it 0.125 watt resistor. Okay? Stop writing. Number 2, we can also have quarter or 0.25 watt resistor. This is the second example. Number 3, we can have a half or 0.5 watt resistor. These are low power resistors, right? And this is the standard one. Whenever, or in most electronics workshop, in most C classes or most engineering programs in Tanzania and most of the countries, we used to interact with 0.5 watt resistors. Half resistor, half power, right? And then another example, we have what? 0.6. So you have 0.6 watt resistor. And if you do remember that, when I've been introducing this concept in Proteus, the lowest power or the low power resistor in Proteus has a power rating, Jackie, of 0.6 watt. So in Proteus, there is no any resistor that has 1/8 or 0.12 watt, 5. Listen, in these simulation tools, in Proteus simulation tools, there is no any resistors that have a power rating of 0.125 watt, right? There is no any resistors that has power rating of 0.25 watt. And there is no any resistor that has 0.5 watt. That's according to survey that I've made. So the low power resistor in Proteus is a resistor of 0.60 watt. Are we together? Okay. So these are the 4 examples. So example number 5, we have also 1 watt resistor. And also number 6, we have 2 watt resistor. So in most cases, low power resistor, listen, low power resistor range from 0.1, let's say that, because range from 0 to 2 watt. Right? The principle, or we say that, the survey in electronics, low power resistor range from 0 watt or 0.1 watt to what? To 2 watt. Right? So you say that, so you say that the range of low power resistance lies between 0.1 watt and 2 watt. And most of these low power resistors are are carbon. We call them these are film resistor or carbon film resistor, or it can be metal film resistor. So that the range of low power resistors lies between 0.1 watt and 2 watt. Are we together? So simply say that this range means that a low power resistor, in other words, a low power resistor has what? Has a power rating less than 2 watt. Then let us go to the second class, which is high power. In case you have any question, don't hesitate to ask in the comment section. For the online community, for the physical student, don't hesitate to raise up your hand. I will give you a chance to ask a question. High power resistance. Say high power resistance. Say high power resistance. This is the theoretical concept of power rating. So you say that the high power resistance These are the resistors which have high power rating. High power rating, or high power or high wattage, just a power wattage, power rating. Class, do you understand? Yeah? Okay, so after defining the high power resistors, which is a new terminology for most electronics technicians and the engineers, then let me give you examples. What the power rating that actual examples? The first example, we have 3 watt. 3 watt resistor. 3 watt high power resistor. And most of them are wire wound. The second example, we have also 5 watt high power resistor. Then the third example, we have 7 watt. We have 7 watt high power resistor. Then the next example, we have what? 10 watt high power resistor. Then the next part, we have also 15 watt high power resistor. And then the sixth example, we also have 20 watt high power resistor. Then the next example, number 7, we have also 50. We have 50. Let me check. Yeah, we have 50 watt, or let's say 100 watt power resistors. Are we together? Class, are we together? Huh? So if this is the case, what do we say? These are the examples. We have low power and high power. You have to know this point because it's very, 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 very important. So let us just cover this concept within a minute. We say that the power rating of a resistor, this is not NB, not. The power rating of a resistor, the power rating of a resistor affecting the size or the size of physical, we say that physical appearance, the size, affect the size of the resistor. So by using your eye, listen. In low power resistor, the low power resistor do not have labeling of amount of power that a resistor can withstand, and I will show you. But the high power resistor, they have a label of amount of power that can withstand, right? But before I demonstrate to you, just I want to teach you that the size of a resistor give you much information about power rating. How? The low power resistors have a small size, and the high power resistors have a large size. That's the concept just I want to make, right? Huh? So how can affect the size? This one. Number 1. The low power resistors, the low power resistors have the small size. Small size. Number 2, the high power resistor, resistors have what? Have the large size. The large size. So the power rating decides also what? The physical size of the resistor. So, however, that I will just teach you in detail later on. Now let me just finalize this concept by showing you different sizes of the power resistor. So all the students, you have low power resistor. So this we call them low power resistor. So here I have some examples of low power resistor. Students, look here. This is the common one, right? So this one is half watt. Say half watt. It is 0.5 watt. So if you allow 1 watt to pass 1 watt, the amount of power of 1 watt, this resistor is going to be damaged. Why? Because the amount of current flowing through it, it has exceeded its maximum amount, right? Then the next one, it's 1 watt. You see the physical size of 1 watt? 1 watt is larger than what? Half watt, right? Then the next one, this one, it's 2 watt. 2 what? 2 watt. We'll discuss later. You see that all the low power resistors, they don't have any labeling of what? Of power rating. So how are you going to know the power rating of low power resistor? Jacqueline, listen and look. You are going to know, or you have, it means that the only thing that can help you to know the power rating of the low power resistor is the physical appearance. Are you together? Are you together? Remember, the smallest C is 1/8 watt, right? Or 0.125 watt. The next one is 0.25 watt, right? Then you have a half watt. So half watt is common. So whenever you see this one, this is half watt. This is what? 1 watt. This is 2 watt. They are not written on top of them. Are we together? Are we together? That's why I taught you and show you. Are we together? Then another concept I taught you about power, high power resistor. So this is a high power resistor of 3 watt. Wonderful, interesting, eh? It can have the same resistance or the same value of resistance as the resistance of this resistor. Okay, so after covering the concepts of power rating of a resistor or resistor power rating, right now let me just do a simple demonstration of low power resistor in order for you to see their size, and then I will mention about their power rating. So this is some examples of 40 of low power resistor. We say that we can classify resistors by using the power rating into 2 classes: low power resistor and high power resistor. So it's low power resistor, this one, this resistor, and this one, and this one. All of these first 3 resistors from right hand side to the lefty, these are half watt. Say half watt. Half watt. It means that the power rating is 0.5 watt. So, but another thing that which you can notice, for instance, for me, when I've been learning this concept, I have noticed 2 things. Number 1, what I've noticed, first of all, I noticed that these low power resistors, they don't have a label of power rating. There's no any number that has been written to indicate the power rating. There is no 0.5 watt written on this resistor, right? That's the first thing that I took a note. And the second thing that I took a note, with these low power resistors, there is no any labeling of its resistance. Because we said that there are the two measurement parameters, resistance and power rating. For the low power resistors, they don't have, or they don't, it means that there is no any mark that shows what its resistance and its power rating. How do you know about its resistance? Then you have to join me in workshop 5.5. I will teach you how you can find the resistance of the resistor. But in case of the power rating, you can identify, or you can find, or you can just define the power rating of a resistor by just using its physical size, or its size, right? Right? So as you say that, the 1/8 watt, it's the smallest, right? It's the smallest in what? In size. And then followed by what? 0.5 watt. Followed by what? 0.6 watt. Followed by what? 1 watt. Followed by what? 2 watt. Are we together? Are we together? So this is half watt. And then we find some other bigger resistor. So this one, do you see this one? So this is also a low power resistor. Its resistance is not shown, and also its power rating is not shown. But according to its size, this is 1 watt. 1, and then this resistor, it has what? Power rating of what? If you examine, power rating of 1.5 watt. And this one, it's a 2 watt. Are we together? So these are the low power resistors. And then another question that I know, or I have been asking myself, where are we using these low power resistors of 1 watt, 2 watt? Because in electronics, we commonly use what? Resistors with, resistors with 0.5 watt. Those are the most commonly used resistors in electronics, right? So comes in my mind, when I've been learning this concept, I ask myself, for instance, where are we going to use this 3 watt resistor? Where are we going to use? So I want to demonstrate to you, and then I'll do the demonstration for the high power. This is the circuit of an amplifier, right? It's audio amplifier. Say audio amplifier. So remember that this is the PCB board, and this PCB board, this is the top surface. And also we have another side of the PCB board, this we call the bottom surface. So in the bottom surface, we just have roots of what? Of the soldering. This is silver, right? But it's conductor, and the copper. On this side, we just have also some roots and also some electronics components. So you have electronics components on this side, and also you have through-holes electronics components on this side. So what do you say that? These are the transistors. All of these are the transistors, and we call them power transistors. Say power transistors. Say power transistors. And these mostly are MOSFET power transistors, right? So these are the power transistors. When you turn on this side, we have a lot of, these are the cables, right? Or sometimes we call that data bus or power bus. So here we have a number of electronics components, right? Are we together? So in this one, you can see that, for instance, this is 2 watt resistor. It has been used here for the particular task or for the particular function. This is what? 1 watt resistor. This is 2 watt resistor. This is 1 watt resistor. This is 1 watt resistor. But again, this is 2 watt, 2 watt, 2 watt, 2 watt, 2 watt, 2 watt, 1 watt, 1 watt. This is 1 watt, and okay. So this is, yes, 1 watt, 1 watt. This is 1.5 watt. So you can just know their values by using the physical appearance. But you can see some other low power resistors, but actually they have a power rating of 3 watt. Are we together? 3 watt. So that's the concept that I want just to demonstrate to you. And then the second demonstration, which I've taught you, the second class of resistor, we call them high power resistor. The value of power rating for the high power resistor range from 3 watt up to 300 watt. Are we together? So in my hand, I have some power resistors. So these are the power resistors that we have. We have another power resistor here, and have another power resistor. So let me just arrange them in such a way that our videographer can take a view of them. So these are the power resistors. So let me just arrange 3 on this side. So these are the power resistor, and also on my, so these are the power resistor, and these are the power resistor, right? So this is, so one, I think that we have to analyze or to examine the power resistor. One thing that we can notice, first of all of these power resistors are called, or we call them, wire wound fixed linear resistor. Do you remember about wire wound? So within this resistor, there is a wire which has been wound to make turns. Are we together? So the nature of the material or the type of this resistor is called the wire wound. Wire what? Wire wound fixed linear resistor. So for one thing which you can notice is this power resistor. Most of the power resistors, I think that most of them, they have a label of the year resistance and the year power rating. Are we together? For instance, this one, let me just take this one. For instance, this one, its resistance is 47 ohm. 47 ohm. And its power rating is 10 watt. How many watt? How many watt? So this one can stand or can allow large amount of current to pass through without a damage compared to this one, which is 2 watt. Right? Are we together? And then we have another one. This one, it's 1 ohm. It's 1 ohm. And then actually its power rating is not, I think that until you check the data sheet, because it's not written clearly. Again, we have here another power resistor. So this power resistor, its power rating is 2 watt. 2 watt, and its resistance is 5.6. So 2 watt, and its resistance is 5.6. Then you have another power resistor, which its power is 5 watt. Excuse me. This one and this one, if you compare them, they have the same side. This is 5 watt, 2 watt. It is 2 watt, 5 ohm. But this one, it is 5 watt, 39 ohm. Some of the power resistor, you have to refer the data sheet in order to understand the label. But the goodness for this one, it has been written. It has been written 5 watt, 39 ohm joules. Right? Let me just write for you on the blackboard. The common labeling of these resistors is this one. The power resistor, in most cases, you'll find that it has been written, for instance, this one is 5 watt and then 39 ohm joule. Right? The other one, it has been written 47, it has been written 10 watt, and then 47 ohm joule. Why do you have joule? Because there is a dispersion of what? Of energy in form of heat. Right? The essence of energy is what? Joule. Are we together? So this is what? 5 watt, 39 ohm power resistor. And then we have another interesting one. So this one is just like the other ones. Sometimes you can just write this number in Google and search its value. Because for this one, it has been written 1 ohm K and U72. So there's its meaning. Okay? Whenever manufacturer make these resistors, they have to make also its data sheet. And then the other one, similarly, I think that the situation, it means that this one, these three resistors have the same value and the same labeling. You see, for these power resistors, their power rating is not shown directly, and their resistance is not shown directly. But they're the numbers or they're the code, which actually that you can search in Google and know their values. Are we together? So that's all about power resistors that we have in electronics. Then comes another question. Where are we going to use them? Where can we find them? The answer of that question is this amplifier circuit. Are we together? So this is our amplifier circuit. It has a number of electronics components, resistors, capacitors, inductor, and then there is a fuse. There's also surface mounting components such as resistor, also surface mounting device, resistor. There's a transistor, there is a potentiometer, there's integrated circuit, there's a MOSFET, but also there is a power resistor, right? High power what? So where are those high power resistor? This is a high power resistor, so let me just turn them in this way so that we can have a clear view. Some of them, yeah. This is the power resistor. What is power rating? 5 watt. Say 5 watt. And then its resistance is 0.25 ohm joule. Then the next one is this one. Its power rating is 5 watt. Its resistance is 0.25 ohm joule. And then the other one is this one, 5 watt. Its resistance is 0.25 ohm joule. Similarly, 5 watt, 0.25 ohm joule. Similarly, 5 watt, 0.25 ohm joules. Similarly, 5 watt, 0.25 ohm joule. 5 watt, 0.25 ohm joule. Wonderful. So tonight you have to dream about what? 5 watt, 0.25 watt, ohm what? You have to dream it at night. Then we have also the same power, high power resistors on this side. Are we together? So again, so this is the amplifier, it's audio amplifier. And actually that it's a kind of, we call just, it's a very powerful amplifier. So when you turn on this side, I told you that these are the MOSFET transistors. MOSFET power transistors. MOSFET power what? So then the questions comes in your mind. I know one of the questions that you are thinking. Fatuma, can I ask you a question? Can I ask you the question that you are thinking to ask? Here it's your question. What the function of these power resistors in this circuit? That's a good question. The function of these power resistors in this circuit, they have been used these high power resistors have been used as fuse to protect the power transistor. To protect the power against the what of our current. Right? So for instance, this power resistor is connected with this MOSFET transistor. So this is acting as a fuse. When there is excessive current, and that excessive current actual that it's more than 5 watt. This power resistor is going to blown out of the image. And when it's blown out of the image, this MOSFET transistor is safe. Wonderful. That's the beauty of electronics. You use another component which is cheap and works actually or just perform that task to protect the other one. It's just like the soldiers. They used to protect the president. So if somebody just want to attack the president, the soldiers have to die first. Are we together? Why? Because the president is expensive more than what? A soldier or a bodyguard. So this is the bodyguard of this MOSFET transistor. 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 So in this MOSFET transistor just need a power rating not more than 5 watt. So today I taught you function number 10 of high power resistor. High power resistor can be used as a fuse. So you can add in a list of 9 functions of the what? Resistors. Are we together? Are we together? Why do we use these power resistors to protect MOSFET? MOSFETs actually perform a great function or perform a lot of function in this circuit. but also they're expensive. While power resistors, they just perform one function to protect the MOSFET. Right? Protect the what? Just to allow current to pass when the power rating is 5 watt or less than 5 watt, and actually to blown out when the power rating is more than 5 watt. Are we together? So if that's the case, so you say that these power resistors are cheap compared to MOSFET. Are we together? Is it clear? Okay, so if you have any question about what I've demonstrated, please ask it. There is no any question? Okay, so let us continue with our movement. So I have shown you that the power rating of resistor actual depend the size, the physical size, or the size of what? Of the resistor. Are we together? Then, so if this is the case, we know that actually we have a good background of mathematics. Let us talk about the mathematical a little bit, because I told you that engineering is all about what? Numbers, formula and equation, diagrams, pardon? Tables, and graphs. So let us talk about what? Formula and the equation. So we are talking about power rating. Are we together? Yeah? So my dear student, just recall this formula. So recall the formula of what? Of power. Of electric power. The formula of calculating, or the formula of finding the electrical power. Finding electrical power. So the formula, if you do remember, we taught you, first of all, we taught that power is equal to what, student? Power is equal to NH from mechanics, NH over time. Are we together? So if you are talking about electrical power, so electrical power, it's a ratio of electrical energy over what? Over time. Are we together? Then we say that, okay, this is one of the equations. Let me just remind you quickly. But also you say that, recall, we have told you that electrical energy can be calculated or computed, and we can just use the symbol E, is equal to what? The amount of current multiplied by time multiplied by voltage. So for that case, this will be equation 2. So let us substitute equation 2 into equation 1. So you say that power, electrical power, we told you that it's current times time times voltage over time. Simply this one we call it ITV, because in Tanzania we have what? ITV, right? ITV, video television station. Okay. So this is ITV. So T and T cancel. So electrical power is equal to IV. So electrical power is equal to product of current and what? And voltage. Product of current and what? And voltage. So this is the one of the formula, just I wanted to remind you. But whenever we talk about the power dissipated, say power dissipated. So always the power dissipated, the element that is dissipating the power, always dissipate that power by using resistance. For instance, you want to calculate the power of electric heater. So actually that the conversions of power from electric energy into heat energy is being done by a resistor or a resistive substance or a resistive element. Are we together? So for that case also, we say that this is our equation 3. Let us recall Ohm's law or Ohm's law equation. So Ohm's law equation simply said that voltage is equal to current times what? Voltage. times resistance. So this is equation 4. Substitute equation 4 into equation 1. So we say that we have electric power is equal to what? Is equal to electric current times resistance. This one is equal to square of the current times resistance. So power dissipated, when you say about it, mostly we use this formula to calculate the power dissipated. Power dissipated by a resistor is square of the current times resistance. So remember that the parameter of power, listen. Remember that the parameter of power rating actually teaches about the current. Are we together? How does it teach us about the current? If you know the amount of power, listen. For instance, in power resistor, for this power resistor, its resistance is 47, right? And also its power is what? 10 watt. You can calculate the maximum amount of current that will be flowing through this resistor without damaging it, right? How? It's simple. We say that power of a resistor is equal to square of the current. So let us find the square root and let us find the square root. So current is equal to the square root of power of a resistor. Also, remember that. Also, we say that. Yes. So also we say that. Voltage is equal to current times resistance. So if you make current a subject, you have resistance. So you have current is equal to voltage over resistance. This will make equation 5. Substitute equation 5 into equation 3. So also another formula of power dissipated. This is equal to what? Square of the voltage over resistance. Square of the voltage of what? Over resistance. So this is the power what? Dissipated. So you may calculate power dissipated by using this formula or this one. But in case, so it means that now, example, a power resistor has 47, has a resistance of 47 ohm, and its power rating is 5 watt. Calculate the maximum current. Of a power resistor. So we can practice this formula by simply just calculating the amount of current. Why did I refer this formula? I know that you are expert in this formula, and actually you did a lot of questions by using this formula. I'm referring this formula. The main reasons is I wanted to show you the relationship between the parameter of power rating and current. Okay? Okay. So if that's the case, we say that's fine. Solution. So, our data given. We have been given power, rating of the resistor. Power rating is equal to what? 5 watt. Then we've been given what? Resistance of the resistor. This is 47 ohm. So what we have been asked to find? we've been asked to find or to calculate maximum current. Maximum what? Current. So maximum current. This is required. You should not retire this method of writing what? Data given. In engineering, we like it to solve problems systematically. So don't have a perception that, data given is just ended in advanced level or in all level. No. That's the systematic way of solving science problem. So now you're applying science to solve engineering problems. So if that's the case, this is the first step. Then the second step, we say that recall the formula of what? Called the formula of power rating. So you say that power, which is P, is equal to what? Is equal to square of the current times what? Resistance. So what are you finding? Current. So current is square root of power over resistance. So if that's the case, this is the square root of what? So 5 what? Or 5 over 47. What the maximum current? Take your scientific calculator or take your mobile phone, take 5 over 47 and then find the square root. Can I clean the next part? I'm talking to you. You are busy calculating. What did you find? 0.33 what? Mangoes. Ampere. Right? So therefore we say the maximum current of a resistor is 0.3 ampere. 0.33 what? That's the maximum amount of current that resistor can withstand without damage. If actually you apply the amount of current greater than 0.33 ampere, that power resistor is going to damage. Is it clear? Is it clear? Okay. This is theoretical or theory concept of power rating. So let me just teach you some few concepts and then we go to the standard power rating of resistors and then we'll be ending our workshop. So you say that the power rating of a resistor, is 1. is one of the more hidden or the more hidden values. Nevertheless, it can be important and it is a topic that will come up when selecting a resistor. So this is not a parameter. Listen, this is not we call it the power rating of resistor is one of the more hidden values. Say hidden values. It's not actually it's not a common parameter of a resistor compared to resistance of the resistor. Are we together? So if that's the case, but this one is important whenever we come to the topic of selecting a resistor. What does it mean? Whenever you want to select a resistor for your project or for your electronic system or for your telecommunication system, then the concept or the concepts of power rating or the fact of power rating will be used in the right choice of the resistor. Are we together? Yeah, that's one of the points that you have to take a note. But another point that you have to take a note, the power rating of a resistor also gives you some important information about the size of your PCB design. When you want to design a PCB, the matter, for instance, this is 47 ohm resistor. Actually, I know that you trust, it means you believe that it's going to occupy large space compared to this one of the same value, right? So it means that we say that power rating also play a great role in PCB design, because this is the PCB board. Are we together? This is a PCB board. So you can find that the high resistor or the high power resistor actually they occupy large space. Okay? Okay. So another point that you have taken note is this one. The power rating of a resistor, is one or plays a crucial role. A crucial role in PCB design. Because it impacts the thermal management, because it impacts the thermal management, thermal management and reliability of the circuit. and the reliability of the circuit. So the power rating class, say power rating. Power rating of a resistor plays a crucial role in PCB design. Why? Because it is impacting the thermal management and the reliability of the circuit. What does it mean? Listen. If you connected this amplifier to electric source or to electric power, then actually that you connect the load, that will be receiving the signal which has been amplified by this power amplifier. Okay? Okay? So when this power amplifier will be working, these MOSFET transistors are going to be extremely hot. Right? So if they are extremely hot, it means that's why also we have this power resistor, because power resistor, they can dissipate electric current or electric energy in form of heat. Are we together? Are we together? Yeah, so it means that in other words, these power resistors that have been used here are used for as a heat sink. Actually to absorb some amount of heat from power MOSFET transistors. Are we together? Is it clear? Okay. Another concept that you have to remember in dealing with power rating, we say that this is another concept. Factors affecting power rating. We are not discussing this in detail, but we just mention them for you to be aware of. Factors affecting power rating of a resistor. So he said that there are several factors. There are several factors that can affect the resistor power rating. The resistor power rating. The resistor power rating. The following are some of these factors. The following are some of these factors. The first factor, we call it size. Say size. Say size. Say size. So size can affect the resistor power rating. The second factor is temperature coefficient. Say temperature coefficient. Say temperature coefficient. Say temperature coefficient. And then the third factor is material. Say material. Say material. Say material. The next factor is called the ambient temperature. Say ambient temperature. Say ambient temperature. Then the next factor is mounting on the PCB board. So these are some of the 5 factors that affect the power rating of of a resistor. If you have any question about what we have discussed up to this time, don't hesitate to ask in the comment section. And for the physical students, don't hesitate to ask, especially for the advantage of online students. So let us end this workshop by learning some standard power rating of resistors. When I have told you about the parameter of resistance, if you do remember in previous workshop 4.3, I mentioned also some standard resistors, right? Some standard resistors based on their resistance. So also we have some standard resistors or called standard or some standard power ratings of the fixed linear resistors, right? That will be our last concept for this workshop. Some standard power rating of fixed resistor. In electronics and electrical engineering, there are some standard power rating fixed resistors of fixed resistors. So the following are the same. So the following are some of those standards. So the first, we have some resistors in electronics that are 1/8 or 0.125 watt. It is a low power or high power? Low power. The next standard value of power rating is 1/2, which is 0.5 watt resistor. The next example is 0.6 watt resistor. Then the next standard power rating of resistor is 1 watt. The next example is 2 watt. The next example, or the next standard power rating resistor is 3 watt. Then we have 5 watt resistor. Then number 8, we have 7 watt resistor. Oh, I'm sorry. I think that here I forgot quarter watt. I forgot quarter watt. So number 9, we have quarter watt. 0.25 watt. Quarter watt. And then number 10, also we have 10 watt. Number 11, we have 15 watt. Number 12, we also have 10, 20 watt. Then we have 15 watt. 15 watt. No, I've mentioned 15, 25 watt. Number 14, we have 50 watt. Number 14, we have 100 watt. Number 15, we have 120 watt. Number 16, we have 200 watt resistor. Number 17, we have 300 watt. So these are some standard power rating resistors. And at the beginning, I think that in this workshop also, I taught you about the low power rating resistors and high power rating resistors. So you may notice that how many resistors do we have in electronics? So before we end this workshop, let me leave the homework for you, because I want to involve you in this process of learning. So here it's a homework. This is homework 4.4. And the homework is actually will be testing, you'll be having 2 questions. Examine the physical appearance and the size of all standard resistors from 0.1 to 5 watt to 300 watt. Hint, use Google. So examine. I've been showing you some examples of low power resistor, and I've been showing you some examples of high power resistor. So listen, listen, listen. So this question actual give you a responsibility, open or actual, widen your thinking and your concepts of resistors in your mind about the power rating. So use the internet, go and write 0.12 watt or the physical appearance, or just write the image of 0.125 watt, or just write 0.125 watt resistor, then search in Google. You see its appearance, right? Again, do the same, just do the same for the quarter watt, do the same for the half watt, do the same. And when you be examining, you have to study. You should not just see and then within a short time, you have forgotten it. Are we together? For instance, I did that task for me. So do you see? So this is the image of the physical appearance of, this is 1 or 0.2, 0.125 watt, right? It is the smallest. Then next, this is black and white, but they have colors, right? So their physical appearance is not like this one. This is because I printed by using white and black, right? Do you see quarter watt? And then do you see half watt? Do you see 1 watt? And do you see what? 2 watt. So you have to do this business and you have to keep in your mind for all the standard power rated resistors that I've mentioned there, right? And then I did the same task for the high power resistors, right? So this is the low power, means that this is the high power resistor with a small value. Then next is this one. So I can read them. This one I cannot read. But this one, this is 5 watt. So this is 5 watt. And this is 5 watt. And this is 25 watt. 25 watt? And this is 25. And then so we have another wire wound. You see this one? So this is 25 watt. 1.2 ohm. So its resistance is 1.2, very small. But power rating is what? 25 watt. 25? So you can calculate the maximum current. The maximum current will be what? The square root of 40. 25 over what? 1.5. Which will be in terms of some numbers of current. Are we together? But the goodness of Google actually see with the ear color. So when you'll be given or when we encounter actual electronic circuit like this one, which is the number of resistors of different physical size, and actually consists in the low power resistor and the high power resistor, so you can study them and you can understand. Because if you know the physical appearance, you can know the function. You can predict the function of the resistor. Are we together? Are we together? So that question will help you to understand and open your mind. Because if just I will teach you how can the break down this or conducting current, this is just one. So in your mind, when you find a wire wound power resistor of this size, you say, this is not a resistor. Because remember that before you do troubleshooting or fixing any problem, you have to know what are the components which are there and you have to understand them. Are we together? So that's why that in this course we are teaching you the fundamental skills. For instance, that until the end of the topic of resistor, if you do revision and you do all the works that I'm going to give you, I want to tell you, my dear student, you'll be understanding and loving resistors day after wherever that you find in electronic circuit. You may open even maybe a flat screen television, and then just will be enjoying to see the resistors which are there. Are we together? Are we together? But I think that I forgot one point to note. So let me just write question number 2. No, this question is enough. Note this one. We say that in most electronics engineering circuits, we are using what? We are using the low power resistor of power rating of what? Of half watt, no, quarter watt. This is the point to note, quarter watt. So we are using in electronics, when you say quarter watt, this is quarter watt. Do you see this one? Can you come? So in most cases of our electronics system, we are using these resistors, right? Why? Because remember, most of electronic circuit, they don't they don't consume large amount, they don't draw much current from the source. Okay? But some of them, like this one, they draw much current. Are we together? So in most cases, even in most of the, just in electronics workshop, most of the electronics workshop, if we be given a resistor, we'll be given a resistor of this size and this kind of the power rating. These are the common resistors in electronics. Are we together? Are we together? But remember that you may even use this one. If you use this resistor in the circuit, the resistor and even the circuit might be more safe rather than if you're using this one. Because if there's excessive current, this one will blown out and can affect some other outcome. Because remember, the function of resistor is to reduce or limit your current. So if it is blown out, it failed to limit or reduce your so the whole amount of current is going to the most sensitive parts. So if that's the case, let me give you a chance to ask a question. But before I give you a chance to ask you a question, let me ask you a question. Attention please, stop writing. Let me ask you one question. Did you understand what we have covered in workshop 4.4? Class, did you understand? Eh? Did you get something new in your mind? Eh? Eh? Wonderful. So if you have understood, myself, I thank God also because even myself who have been teaching you, I understood what I've been teaching you. Because sometimes you might teach and you don't understand what you are teaching about. So I thank God who have given me a gift of teaching, and I thank you who have joined me in this program. I would like to invite you in the next workshop, that will be workshop 4.5, where that I'm going to teach you about the resistor color coding. Resistor color coding. And then we'll talk a little bit about ohmmeter, and then that will be enough for the theory of resistor. So in case that this is your first time, my name is Olenjolai. Just to remind you, I'm from Tanzania. I love so much my country. And these are the content that I'm creating. And actual my intentions is to spread this knowledge into entire country of Tanzania. So if you are watching from Ruvuma, just tell us in the comment. If you're watching this video from Dodoma, just tell us in the comment that we are watching or we are learning electronics in Dodoma actually without any limitations of the resources. But again, you might have some other questions about how can you get electronics components such as resistors for you to be a practical technician or practical engineer. I just want you to stay connected in our official YouTube channel. Then I'll give you the just the way, but just the simple way. You may, in case you have any private questions or anything else to share, you may just call me. Can call me or check me on WhatsApp through this phone number 07597453. In case that you need resistors or you need maybe a measuring instrument such as digital multimeter, or you need electronics components to cover these contents of 40 of fundamental, then just don't hesitate to make a call. If you're in Tanzania, I'll try my level best to make sure that you get the resources in order for you to move forward. So if you have any question, you may ask in the comment section. But I ask you also to share this content to other students who love electronics, who love biomedical, who love telecommunication engineering. Just to share with your students, because right now the knowledge of electronics or the knowledge of engineering is actually using the power of the internet to be distributed into different number of passionate electronics engineer and technician. So if that's the case, thank you very much. May God bless you. See you in the next class.